For my science experiment, I chose what is the best angle setup for solar panels? I'm especially interested in solar panels because they serve as a way for communities to become less dependent and because they're also really cool. So, as more carbon gets released into the air and those sources like oil become more limited, renewable energy, specifically solar, becomes more important. Solar panels can take the infinite energy of the sun and they can convert it for everyday use. They also help communities be less dependent on the grid and they can store energy through batteries to be used later. So the research question that I had was, what is the best angle for New York City residents to maximize energy capacity capture? My hypothesis was that panels set at higher angles will do better, specifically around 45 degrees, because they are more direct to the sun. Additionally, when I'm in the car, I see most of these panels being set up at higher degrees. So here's our methods, and the goal is to find which panel angle results in the highest energy capture. So the independent variable, which is the thing we're changing, is we took three panels, a 0-degree panel, a 30-degree panel, and a 45-degree panel. We also changed the time of day. So we did a morning schedule, an afternoon schedule, and a evening schedule. And then the weather also changed. The control variables, so this is the things that do not change from panel to panel. So the solar panel type and brand, we used the Anchor Solar. We used the battery type, same battery, which is an Anchor Nano Panel power bank, and then also the start level of battery charge. The control group, which is the thing that is not changed, is the panel at 0 degrees. Okay, so here's our methods. So first we checked the weather apps. This time we used weather.com and we made sure the probability of rain was less than 5% so the panels wouldn't break. Then we set up the panels at start time on the apartment roof. Each panel was connected to their own battery, fully drained. We used a protractor to verify the angles were the same. And we made sure all the panels were oriented south. So then what we did is we collected the battery charge data at the end. And then we also measured the sun strength. So we repeated this entire experiment 3 times for each of these time periods. Okay, here's a photo of what it looked like. So on the left side here, you can see that this is the 0-degree panel, so flat. This is the 30-degree panel, and then this is the 45-degree panel on the highest angle. And then you can also see the Anchor battery bank that we used. Okay, here is our result. So you can see that we measured it and we put in the test date, we put in the sky condition, we measured the temperature, we measured the gain for each battery. So for the 0% here, you can see it was 80%. And then you can see that here in all of our tests, the 45-degree did the best. Okay, and here's a summary of all of our data. So when it was sunny, the max it would get is 93% at a 45-degree angle. When it was cloudy, it averaged around 25%. And then when it was cloudy, the least it got was 1%. So you can see that when it's sunny, it does a lot better than everything else. However, you can see that the solar panel at 45 degrees still does better than all the other 3. Here's my conclusion. So the solar panel with the highest degree angle for 45 degrees in the sunniest conditions does generates the most energy. So in all 9 of the tests, the 45-degree panel captured the most energy, right? This was true regardless of sun conditions or even the time of day. And despite the conditions, the 45-degree panel still did the best. Okay, so here's some of the problems that we faced. So initially, we conducted it during cold temperatures and there was rain. So initial experiments did not work and the batteries just didn't work. And we tried to problem solve with winter gloves and hand warmers, but the batteries still didn't work. And many days had rain. So we learned that solar panels have difficulty functioning in the rain and cold. And because this experiment is weather dependent, it's important to have many months to plan. To address these problems, some things that we could do is to test the same thing is maybe we could conduct this in a greenhouse and maybe we could conduct this experiment earlier to give more time. Here's some ideas that we want to ask next and maybe future projects. So do even higher angle panels perform better? So we've seen that 0 does the worst, 30 does okay, and 45 does the best. So does 60 degrees do even better? I was thinking that are there certain brands of solar panel that do better? Like, do they use a different system? Are there different brands of batteries that better capture solar energy? And then maybe are there better locations? And then the next energy project that we might pursue is what is the best solar panel setup? Okay, so here's a future next project that we would do. So maybe what we could do is we could test increased angulation. So we could maybe go all the way up to 90 degrees and we could see if that improves the output. And then, yeah, that would also include determining the ratio. We could also test different seasons to see if certain seasons do better than the other because of the sun height in the sky. So I just wanted to say thank you to my teacher, Miss Pabe, for her mentorship and supporting my science fair project. I appreciate her helping me with the methodology. And I also want to say thank you to the workers in my apartment building who opened roof access when the roof was closed due to the weather and time of year.